All right, our third example is when we're comparing grams and then you want to find out how many liters of something is produced at not at STP. We're going to do this very similar to how we did gram to gram stoichiometry in our previous units. Now I've got 12 grams of butane with 150 grams of oxygen. Now that's a lot more oxygen, even though it's 13 to 2, but oxygen only has a 32 molar mass. So I'm going to believe that butane is our limiting reactant here. Okay, so let's go ahead and think that that's true. So I'm going to take 12.0 grams of butane, the C4H10. I'll multiply that by 1 mole of that butane over a molar mass of 58 grams of C4H10. I, of course, will multiply that by 13 moles of oxygen over 2 moles of C4H10. And I'll times that by 32.0 grams of oxygen, because that's its molar mass, per 1 mole of oxygen. And that gives me an answer of 43 grams of oxygen. I've been given 150. 150 is a lot more than 43. As I suspected, then butane is our limiting reactant. So I'm going to go 12.0 grams of butane. I will then go times 1 mole of butane over its molar mass, 58 grams of C4H10. I'm going to use that limiter to figure out how much carbon dioxide, so I'll say times 8 moles of CO2 over 2 moles of C4H10. Okay, and that gives us 0.828 moles of CO2. That's what's produced. Now, of course, we want liters, so now I just go to PV equals nRT. So I'm going to go 120 multiplied by volume equals 0.828. Multiply this by 8.31. And I'm converting that 40 degrees again into Kelvin. And my volume of carbon dioxide produced is 17.9 liters of CO2. Notice again how we always use a limiter through to figure out the volume of our gas produced. And those are 3 examples of doing gas stoichiometry and limiting reactant.